Okay, today I want to talk about section 11.8, the power series. This is like outline. I want to talk about definition of a power series. How to check whether a power series converges or diverges. Third one, the definition of radius of convergence and interval of convergence. The first one, this is definition. What is like a power series? The power series is summation from n equal to 0 to infinity, c sub to n x to the power n. This is like expanded form. The c0 plus c1x plus c2x squared plus c3x cubed. This is like the variable x that we call function of f of x. The x is a variable, the cn like a constant, called the coefficient of the series. What's like a domain of f? The domain of power series is the set of all x values for which the series converges. So this is like a domain. This is an example. Find the domain of f of x summation from n equal to 0 to infinity, x to the power n, 1 plus x plus x squared plus x cubed plus x to the 4 and so on. So let me see. So how can you find the domain? So what's that? So you need to find the all set of x values for which the series converges. Which x value has convergence series? So what kind of x values? So what do you think? So could you write answer? So how can you find the domain of f of x? Do you know some idea? So let me see. This one is like power series. So can I show to you? The next one. The power series is in this case, geometric series. Summation from n equal to 1 to infinity, 8 times r to the n minus 1. So we have a conversion result if the absolute value of common ratio is less than 1. The series is divergent if the absolute value of common ratio is greater than or equal to 1. So we have these two kind of result. So what's that? So this is exactly geometric series. Here, in this case, what is A? So what is A in this one? What is A? So what is A? What is the root of A? The A is, what's that? So this one, so what is A? Yep, thank you. A is 1. This is 1 is the root of A. So like this, what is R? So what is R? The R is here. No, this is R is like X here. This is what? 1 plus 1 times X plus 1 times X squared plus 1 times X cubed. So like this, exactly, the X is R. How can you find the X? 1 times X. How can you find X squared from X times X? How can you find x cubed from x squared times x? How can you find x to the 4 from the x cubed? X cubed times x. Exactly, x is common ratio R. So when we have a conversion result here, absolute value of R is less than 1. So we have the absolute value of R is, absolute value of x is less than 1. This is same to x is between the negative 1 and 1, so like this. So what's like a domain? the domain of this function f, we can denote this is like function f of x. Domain of f is here, the set of all x for which the series converges. So we have convergent result, x is between -1 and 1. So domain of f is open interval -1, 1, like this. This is domain of the function. Okay, this is idea, like this. The next example, more generally, a series of the form summation from n equal to 0 to infinity, the c sub to n x minus a to the power n was expanded from the c0 plus c1 x minus a plus c2 x minus a square plus c3 x minus a cube and so on is called a power series in x minus a, or a power series centered at a, or a power series about a. The one remark, x equals a, the what happens? You can plug a into here. You can plug this a into here. This one, exactly, the a minus a is 0. A minus a squared is 0. A minus a cube is 0. What's that? This is exactly C0. What's like C0? C0 is finite number. But what does it mean? This series has finite number. Exact meaning is convergent. Converges if x equals a. So this is one good result. So what does it mean? So here, series always convergent at a. Is right. We call what's a? The center of the series. The center of the series. This is like one remark. So here, the one question. For what values of x is the series summation from n equal to 0 to infinity n factorial x to the n convergent? Remember, so series is given. The series is convergent or divergent. How can you check? We learn the 7 tests. The test for divergence, integral test, direct comparison test, limit comparison test, the ratio test, the root test, and the alternating series test. The which test is possible for checking this series is convergent or divergent? Which test is possible? The which test do you want to use for checking the series is convergent or divergent? So what do you think? The which test is possible for solving this series problem? Yes, ratio test, it's good because series involve factorials or other products, including a constant raised to the nth power, c to the n, c to the 2n, c to the n square, some factorial forms. We use ratio test, yes. So you calculate. So what's that? So this is the same to the like this. So we have limit. N is going to positive infinity. Was it like an plus 1? You plug n plus 1 into this n. So we have absolute value of n plus 1 factorial times x to the n plus 1 over an is n factorial times x to the n. Do we have it? The next, you have to expand. This n plus 1 factorial is exactly same to n plus 1 times n factorial. x to n plus 1 is same to x to the power n times x to the power 1 over the n factorial times x to the n. The next, cross out n factorial, cross out x to the n. So let me see. This is a limit n approaches infinity, absolute value of n plus 1 times x. So we have the like this. The one more. Was it like n? N is positive integer. Like in this case, from 0 to infinity. So we have 0, 1, 2, 3. You plug these numbers into n. N plus 1 is always a positive number. You can take out positive number n plus 1. N approaches infinity. The n plus 1, the one more. What's that? What is x? X is a positive number? So what do you think? X is a positive number? X is a positive? So what do you think? So what is x? X is a positive? So x is, we don't know. X is like a variable. Sometimes positive, sometimes negative, sometimes zero. So what does it mean? Always keep x like this. So what happens? N plus 1 approaches infinity in this case. So what is n plus 1 times absolute value of x? What's that? What's it like n plus 1 times absolute value of x? Infinity? Depending on. So if x is like non-zero, we have infinity. You're right. So if x equal to 0, what's x equal to 0? 0 times n plus 1 is always 0. The limit of 0 times n plus 1 is 0. Limit of 0. The limit of 0 is 0. We have two possible answers. So what happens? X is not equal to 0. The limit value is infinity, is greater than 1, always divergent. X equal to 0, what's that? Less than 1, convergence. So what kind of value x? Only 0. So we have this result. Series n equal to 0 to infinity, n factorial x to the n is convergent. When x equals center 0. That's it. Only 1 point. Like this. We have it. The x is just the center. Like this. Here, for what values of x does a series convergent? The same question. So which test can you use for checking the series is convergent or divergent? So which test do you want to use? So which test? The test for divergence, integral test, direct comparison, limit comparison, alternating series test, ratio test, or root test. So which test is possible for checking the series is convergent or divergent? So what do you think? So which test is good? Like ratio again? Yes, because x minus 3 to the power n is like c to the n form. We can use ratio test again. It's good. So you can calculate. So what's that? This is same to limit an plus 1 times 1 over an. So we have limit n approach infinity was like an plus 1. You plug n plus 1 into this n. So we have absolute value of x minus 3 to the power n plus 1 over the plug n plus 1 into bottom one, we have n plus 1 times 1 over an is the reciprocal of an, only flip. So we have n over x minus 3 to the power n, like this. So what's that? This is a limit n approaches positive infinity. The absolute value of, so what's that? X minus 3 to the power n times x minus 3. You have to split over n plus 1 times n over x minus 3 to the power n. You have to cross out x minus 3 to the power n. So we have limit n approaches infinity. Or close here. N over n plus 1. The absolute value of n over n plus 1 times x minus 3. So like this. So let me see. N is going to positive infinity. So what happens? N over n plus 1. The infinity over infinity. I want to ignore lower term. Cross out n. This is exactly same to keep absolute value sign. X minus 3. So like this. So when do you have a conversion result? We have this value is less than 1. We have conversion result. Is right? Conversion result. So, so which one? So we solve this one. Absolute value of x minus 3 is less than 1. So we have like this one. X minus 3 is between minus 1 and 1. You can just split like this. Is it possible? So you add 3 to each side. So what's that? So we have 2 x to 4. So what does it mean? The series is convergent in this interval. This is your final answer. So what's your like answer? Answer is like this. So what is your like x value? X is between 2 and 4. So that's it. This is your final answer. What do you think? So what do you think? Is it final? Is it final? So this is not a final answer. Because, so to remember this one, you can use ratio test the limit of absolute value of an plus 1 over an equal to 1. So what's that? Inconclusive. So we don't know. You have to use other test. So what does it mean? So this limit value n approaches infinity, absolute value of an plus 1 over an. This is equal. This is same to this one. So from the previous calculation, equal to 1. What's that? Inconclusive. So in this case, you have to use other test. So what does it mean? You can check. You can check if the series is convergent or divergent at the end point 2 and 4. You plug 2 into here, 1. Plug 4 into here, 1. Just only check at end points 2 and 4. the 2 and 4. So what does it mean? You plug 2 and 4 into original series. You have to check the series is convergent or divergent. This is one more thing. Do you need this problem? So here you calculate like this. So you solve. So we have inconclusive. You can check x equals 2. You can plug x equals 2 into here. So what's that? We have this one. You can plug the 2 into here. So we have 2 minus 3 to the power n, exactly same to minus 1 to power n times 1 over n, so like this. So the series is convergent or divergent? What do you think? The series is convergent or divergent? Convergent or divergent? Do you have any idea? This is like your previous like second midterm exam. So what do you think? This series is convergent or divergent? Convergent. So which test do you want to use? So what kind of test do you want to use for solving this problem? Yes, alternating series test. Do you remember alternating series test? Alternating series test. So we have alternating series. So like this. So satisfies two conditions. The first condition is sequence Bn decreasing. The second condition, the limit of Bn. Limit of Bn, n approaching infinity equal to 0. What's the answer? Answer is alternating series is convergent. This is whole idea. So here, what's it like Bn? The Bn is only positive part 1 over n. This 1 over n is Bn. You can check. First condition, sequence Bn is decreasing. Very clear because 1 over 1 plug 2, 1 over 2, 1/3. Number is less, less, less. This is decreasing. Another one, limit of sequence Bn is going to 0. Yes, going to 0. So satisfies two conditions. What's that? Series is convergent by using alternating series testing. Alternating series testing. This is like whole idea for solving this problem. Yes. X equals 4. You can plug 4 into here. So we have it. What's the 4 minus 3 to the power n? This is 1 to power n. 1 to power n is always 1. So this is the same to summation n equal to 1 to infinity, just to 1 over n. So like this. So what do you think? Summation 1 over n is convergent or divergent? Convergent or divergent? Divergent. So why? Why this is divergent? Why? So do you have any reason? In this case, we can use P series. What's P series? The summation 1 over n to power p. We have two possible answers, converge or diverge. So if power p is greater than 1, convergent. Power p is less than or equal to 1, divergent. In this case, power p is exactly 1. P equals 1, divergent. So like this. So what is like answer? You have to include 2. We have conversion result. You have to add 2 in here. This is answer. Like this. Okay, this is like a whole idea for solving this problem. The next one. Find the domain of Bessel function of order 0 defined by j0x equals summation from n equal to 0 to infinity minus 1 to power n x to the 2n over 2 to the 2n times n factorial squared. Let me see. So how can you find domain? What does it mean? The question is exactly same to the previous examples for which values of x has convergence series. To find x values, the same. You can use ratio testing. You can change it like this. So what's that? So this is the same to here. This is a limit n approaches infinity. You can plug n plus 1 into here, n. This one. So we have minus 1 to n plus 1 times x to the really be careful, 2 times parentheses n plus 1 over here, same, 2 to the same, 2 times n plus 1, plug like this, times the here, just n plus 1 factorial squared. This is exactly an plus 1 times 1 over n. What's 1 over n? Reciprocal. Only flip. Numerator, denominator. So 2 to the 2n times n factorial squared over minus 1 to n x to the 2n. So like this. So let me see. So we have absolute value sign. So what does it mean? You don't need minus 1 to n. You have to ignore minus 1 to power n plus 1. And so what's it like here? So let me see. What's that? This one is exactly same to x to the 2n plus 2. I want to split x to the 2n times x square form. You have to split. So we have limit n approach infinity. So here x to the 2n times x square. Similar. What is 2 to the 2n plus 1? Split. 2 to the 2 times n plus 1. You have to split. 2 to the 2n plus 2. So we have 2 to the 2n times 2 square. You can split the 2 to the 2n times 2 square. The next one, n plus 1 factorial square. You can split n plus 1 factorial is exactly same to n plus 1 times n factorial. What's that? We have square. So you have to take square. So like this. Next, you have to distribute power to the first and second one. This is same to n plus 1 square times n factorial square form. You have to split. So we have n plus 1 square times n factorial square times, so second part, 2 to the 2n times n factorial square over x to the 2n. You can take absolute value here. So you have to cross out common things. 2 to the 2n is crossed out. X to the 2n is crossed out. And factorial square is crossed out. So we have this one, limit n approaches infinity, the absolute value of x squared over the 2 squared is 4, n plus 1 square, like this. So 4 times n plus 1 square is positive number. The x squared is also positive number. So you don't need absolute value sign. So either is fine. Without absolute value, with the absolute value, it's good. What is the answer? So what is the answer of this question? So what is the answer? What is the limit? The x squared over 4 times n plus 1 square. What is the answer? What's the limit? So what do you think? What's the limit? Here, what is x squared? X squared is like constant. You plug 5, the x squared is 5 squared, like 25, like constant. This is constant. N is approaching infinity. What's the bottom one? The bottom one approaches positive infinity. What is constant over infinity? What's a constant over infinity? Yes. Always 0 is less than 1 for all x. So what does it mean? The series is convergent for all x values. What's the domain? Domain is all real numbers. This is the idea for solving this problem, like this. It's good. So you just only summarize previous 3 examples. Do you remember? Was it like a first example? The first example, what happens? The first example is conversion at 1 point, center 0. The second example, so conversion in some interval, half closed interval. The third case of this one, the series is conversion for all x values. We can combining these 3 examples. We have one important theorem here. For a given power series, summation from n equal to 0 to infinity, c sub 2n x minus a to the power n. There are only 3 possibilities. First possibility is the series converges only when the center x equals a. The series converges for all x values. Last one, there is a positive number r such that the series converges if absolute value of x minus a is less than r, diverges. Absolute value of x minus a is the greater than r. So in this case, we can define radius of convergence. The first one, was it like a radius of convergence and the first one? So what is the length of 1 point? Here we have, how can they define the radius? This is ideas like this one. Here, this is 1 point, A. Was it like a length of 1 point? Length of 1 point is like 0, you're right. The divided by 2, this is like a radius, like 0. So radius convergence is 0 at 1 point. What's interval of convergence? Only 1 point. You can use sen notation. This is interval of convergence. Second case, the series converges for all x values. Was it like for all x values, all real numbers? Was it like length of all real numbers? The length of all real number is, what's the length of a real line? What's the length of a real line? What's the length? Yes, infinity. You're right. This is like infinity divided by 2. This is also infinity. The radius convergence is infinity. What's like interval of convergence? So interval of convergence is all real numbers. You can use the like this side. like this. Third one, what's the radius convergence? Here, this is radius convergence, like R. Because the absolute value of x minus a is less than R, this number is exactly radius of convergence. What's like interval of convergence? The interval of convergence is we have these possibilities. You can solve this inequality. X minus a is between the negative R and positive R. You have to add a to each side. So x is between a minus R, a plus R. So we have three possibilities depending on endpoints included or not. Endpoints are not included. We have open interval here, a minus R and a plus R, just open interval. Sometimes only one side included. Another possibility is left-hand point is included, have a closed interval, a minus R, a plus R, like this. The third case is right-hand point is included. We have a minus R included, right-hand point, a plus R, like this. The last one is the both end points are included. Exact closed interval, a minus R, a plus R. So we have four possibility in third case. This is like a whole idea. So like this. So let me see. So we are going back to previous example. Remember this case? Summation n factorial x minus n converges when x equal to 0. What is radius of convergence in this case? What's the radius of convergence? So radius convergence, yes, 0, because so only 1 point 0. So length of point is 0 divided by 2. This is always 0. So what is interval of convergence? Interval of convergence is, what's interval of convergence? Only 1 point, x equal to 0. So like this. One more example. In this case, converges when you can try by yourself, x equals 5. Only 1 point. What's the radius of convergence in this case? The radius convergence is, yes, same 0, only length is 0. What is interval of convergence? What's interval of convergence? Yes, 5. Center. This is like a key for solving this problem. The next one. In this case, the convergence for all x values of x. The radius convergence is all x values. What does it mean? All real numbers. Length is infinity. The interval of convergence is the minus infinity to positive infinity. The third one. So x minus 3 to the n of n converges for x is 2 to 4. The next one. What is radius of convergence? What's the radius of convergence? In this case, what's the radius of convergence? How can you find the radius convergence? You can check the length of this interval. What's the length of this interval? The length of this interval is exactly the right-hand point minus left-hand point, like 4 minus 2. What's it like radius? Always divided by 2. 2 over 2 is 1. So we have 1. So like this. What's it like interval of convergence? Interval of convergence is the half closed interval 2, 4. Only the left-hand point is included. This is like a whole idea. So how can you find radius and interval of convergence? The main tool is ratio or root test in section 11.8, like a power series problem. Usually use ratio or root test as main tools. But here, find the radius of convergence and interval of convergence of this series. So how can you find? So which test is possible for solving this problem? Ratio test, the root test, which one? The ratio test or root test. So which one is possible? The ratio test or root test. So which test is possible for solving this problem? The ratio test. So what do you think? Is it right? The ratio test? The ratio test is possible? Yes, you can do ratio test because this is what? Constant to the power n, the x minus 2 to the power n, you can use ratio test. So this one doesn't have a power n. So you don't use like the root test, but I can change it. The problem is n equal 0 to infinity. The negative 3 to the power n, x minus 2 to the power n over the n plus 1 to the power n. We have all power forms like this. What's like the best way? In this case, we can use root test is better. Like this, right? Depending on what kind of form do we have. So in this case, denominator doesn't have the constant to the power n form, so don't use root test. The ratio test is the best choice. You can change it like this one. Here, how can do that? This is a limit n approach infinity. The absolute value of, you can plug n plus 1 into here. Plug into here. So we have negative 3 to the power n plus 1 times x minus 2 to the power n plus 1 over the square root of n plus 1 plus 1 times the 1 over an is reciprocal of an. Square root of n plus 1 over the negative 3 to the power n times x minus 2 to the power n. So like this. The next t. So what's that? So this is change limit. And approach infinity, you have to expand. The negative 3 to the n plus 1 is the absolute value of negative 3 to the power n times negative 3 to the power 1. Similar. X minus 2 to the power n plus 1 is x minus 2 to the power n times x minus 2 over the square root of n plus 2 times, so square root of n plus 1 over bottom one is negative 3 to the power n x minus 2 to the power n. Close like this. You have to cross out common factor. Cross out x minus 2 to the power n, cross out. So we have this one. This is a limit and approach infinity. So what's that? You have to keep negative 3. So absolute value of negative 3 times x minus 2 times square root of n plus 1 over square root of n plus 2. So like this. It's like limit n approach infinity. So what's that? This is like absolute value sign. So you don't need negative. You can change positive here. The one more, take out 3. The square root of n plus 1 is also positive. Take out the root n plus 2. So we have 3 square root of n plus 1 over the square root of n plus 2 times absolute value of x minus 2. The n is approaching infinity. This is infinity over infinity. Ignore lower terms, cross out square root of n. Answer is 3 times absolute value of x minus 2. This is convergence if this limit value is less than 1. So we have it. So you can solve this one. So what's that? So divided by 3. So we have like this. This one is same too here. The absolute value of x minus 2 is less than 1/3. Next, you have to eliminate absolute value sign. X minus 2 is between negative 1/3 and positive 1/3. Next, you add 2. Each side, 2 is like cancelled. Minus 1/3 plus 2 is here. What's that? We have x is the 5/3. 1/3 plus 2 is exactly 7/3. So in this case, we can find radius of convergence. Was it like a radius of convergence in this case? The radius of convergence is here, 1/3. How can you find? Another method is here. 7/3 minus 5/3. Always 7/3 minus 5/3. You can find the length divided by 2. So we have 2/3 over 2. This is the 2/3 times 1/2 is 1/3. The 이동 is fine. This is 1/3. We always have it. The absolute value of x minus 2 is less than 1/3. 1/3 is radius of convergence. Was it like interval of convergence? You can check end point. What's end point? X equals 5/3, x equals 7/3. So case 1, you can check one end point, x equals 5/3. 5/3. You just only plug this value into here. This x, what's that? The summation n equals 0 to infinity, the negative 3 to the power n. So 5/3 minus 2 to the power n over square root of n plus 1. This is a summation n equal to 0 to infinity. You have to simplify. Negative 3 to the power n times, this is 5/3 minus 2 is minus 1/3. Minus 1/3 to the power n over square root of n plus 1. You have to combine. Do you know this one? A to the n times b to the n is given. You can combine base. A times b to the power n, like this. So you can combine summation n equals 0 to infinity. So top one is combine. Negative 3 times minus 1/3 to the power n over square root of n plus 1. So what's that? Summation n equal to 0 to infinity. The negative 3 is crossed out, only 1 to power n. 1 to power n over square root of n plus 1. Was it like 1 to power n? Was it 1 to power n? What's that? Yes, this is 1. So we have 1 over square root of n plus 1. So let me see. This series, the summation of 1 over square root of n plus 1 is convergent or divergent. Divergent by using P series. Is right? This one is exactly same to 1 over n plus 1 to the power 1/2. Power 1/2 is less than or equal to 1. This is divergent by using like a P series. This is divergent. Would you like a second case? The second case is you plug right in the point 7 over 3 into x. So we have x. So we have x equals 7 over 3. Right in the point, you plug. Summation n equal to 0 to infinity. Negative 3 to the power n times 7 over 3 minus 2 to the power n over the square root of n plus 1. So this is summation n equals 0 to infinity, the negative 3 to the power n times the only 1/3 to the power n over square root of n plus 1. So this is summation n equals 0 to infinity. We can combine. We have negative 3 times 1/3 to the power n over the square root of n plus 1. So what's that? Summation n equals 1 to infinity. Top one is minus 1 to power n over the square root of n plus 1. So this series is convergent or divergent. So what do you think? This is convergent or divergent? The series is convergent. Yes, convergent. Which test do you want to use? Which test? That is similar to the second example, the today. Yeah, you're right. By using alternating series test. This is convergent. So what's your final answer? The interval of convergence is only include 7 over 3. So just exclude 5/3. Include 7/3. We have a closed interval. This is the whole idea for solving this kind of problems. Okay, this is like this. The same to my explanation today, so like this. So this is all for today's lecture. If you have any question, please write your question on the chatting board. If you don't have any question, you can leave live session. I thank you very much for attending my class. I appreciate it. Yep. So if you have any question, just write your question on the chatting board. If you don't have any question, you can leave this live session. Thank you. Have a good day. Thanks.